Okay, class, today we're going to talk about something called mean absolute deviation. Okay, so the standard we're working on today is 811b, which says we're going to determine the mean absolute deviation and use this quantity as a measure of the average distance data are from the mean using a data set of no more than 10 data values or data points. Now the one word in here that's really important that we need to understand is this one right here, mean. Okay, because that's found in mean absolute deviation, and it's also found down here. Mean, if you remember correctly, is nothing but the average. It's where you take the whatever numbers are in your data set, we add them all up, and we divide by however many numbers we have. Okay, so let's talk about mean absolute deviation and what it really means. Let's kind of break it apart. Mean absolute deviation basically means mean is average. Absolute is referring to a positive value, because anytime we deal with absolute value, I'm asking for how far is that number away from zero. Distance is always going to be positive. And deviation means distance from the center. Okay, so when we're talking about mean absolute deviation, I'm talking about the distance a number is from the mean, and it has to be the positive distance of that. Okay, so the true definition is this. Mean absolute deviation, or MAD for short, of a data set is the average distance between each data value and the mean. Mean absolute deviation is a way to describe variation in a data set. Okay, so let's look at an example of this. Okay, first let's talk about the steps. There's 3 steps that we need to follow in order to find mean absolute deviation. The first thing that we need to do is we need to find the mean of our data values. Okay, so that means whatever values we have, we need to add them together and divide by how many values we had. Okay, then the second thing is we need to find the distance each one of our data points, each one of our values is from the mean. So there's going to be a subtraction problem in there, and we need to subtract the mean from each value, but ignore the minus sign once we get that on the calculator. Okay, then we need to find the mean of those distances. So we then take those distances there, the distance each number is away from the mean, add those together and divide by, again, how many numbers we had in our data set. So let's look at an example. So here's an example. We have the data of 3, 6, 6, 7, 8, 11, 15, and 16. First thing we do, step 1, find the mean of our data. So we add all these points together, we get 72. There's 8 data points, so I divide that by 8, and I end up with 9 as my mean. So beside each one of my data values, I'm going to place, I got to find out how far that number is away from 9. So I do 9 minus 3 is 6, 9 minus 6 is 3, 9 minus 6 is 3, 9 minus 7 is 2, and so on all the way down. But you'll notice when I do 9 minus 11, that should be a negative 2. Okay, but we still just leave it as 2, okay, because we need the positive distance. Distance is always positive. So now that I found all the distances each number is away from the mean, we then take those values, add those together and divide by 8. So our mean absolute deviation in this particular case is 3.75. That tells us that our data is pretty spread out. When you look at the values of 6, or actually the values of, 3 to 16, that tells you that, the average distance each number is away from the mean is quite a bit. Okay, the closer this mean absolute deviation is, the tighter our data, or the better our data. Okay, we really don't like data that's real spread out. We like data to be fairly tight. So let's see if we can do a couple of examples, and then we'll see how this is tested on STAR. So here is our example. We have the values of 10, 7, 13, 10, and 8. So one way to actually help us calculate the mean absolute deviation is if we divide things up into 4 columns and actually record our information. Okay, so we write our data down. So we've got 10, 7, 13, 10, and 8. Now the first thing that we're going to do is we're going to add all these values up and come up with the mean. Well, I've already done all that to kind of speed time up. If we add all these together, we end up with 48. We divide that by 5, and you end up with, I believe it's 9.6. Okay. So we write our mean down, 9.6 all the way down. And now what we need to do is we need to find the positive difference between the data point and the mean. Okay, so we want the positive distance. So what I'm going to do is I'm going to I'm going to do the subtraction, but I'm going to go ahead and do the absolute value of that. So it's going to be positive. So if I do 10 minus 9.6, I know I'm going to get positive 0.4. If I do 7 minus 9.6, I'm going to get negative. I'm going to get a negative number first off. I'll get a negative 2.6, but I don't want it negative, so I'm just going to write it as 2.6. Okay, and then I do 13 minus 9.6, and I get 3.4. And I do 10 minus 9.6, I get 0.4. And then 8 minus 9.6, again, I'd get a negative value of 1.6. So I'm just going to write it as 1.6. Okay, so that is step 1 and step 2. Step 1, again, is find the mean. Okay, step number 2, subtract the data value and the mean and get the positive distance between those numbers. Okay, third step, okay, we have to find the average of our differences, or average of our distances away from the mean. So when we add all this together, we end up with 8.4. If I divide that by 5, okay, so that is our division, because we've got how many data points, that's what the count stands for. So our mean absolute deviation in this particular instance is 1.68. So that tells us that, the smaller that value is, the tighter your data value. Okay? Okay, and 1.68 is a pretty good mean absolute deviation. That tells us our data is fairly tight together. There's not a lot of variation in our data. Now let's look at it in terms of star. Okay, so in this one it says the list shows the number of songs that 5 students each downloaded last week. Okay, what is the mean absolute deviation of the numbers in the list? So key in this particular problem is mean absolute deviation. Okay, so that tells us that we need to add our values together, divide by 5, find the distance each number is away from the mean, and then find those averages. So with that in mind, we look at our answer choices. And there's 2 answer choices that you should be able to eliminate right off the bat, because they can't be an average distance from the mean. Okay, just if you pay close attention, you know that A and C can't happen. Those 2 numbers are too big, because the mean is going to be somewhere in the middle of the data values, somewhere between 28 and 51. And then when we look at our distances, it just doesn't work. Okay, so now when you calculate that out, okay, you calculate, because the average of this, if you were to look at the average, is 34 or 38.4. Okay, that becomes our average. Okay, that is our average. So if that is our average, we then calculate the difference each one of these numbers is away from this. Okay, and it can't be either one of those. Okay, so it's got to be either B, or D. Now, when you calculate it out, you find out that B is our correct answer. Okay, so that is how we do mean absolute deviation and how it's tested on the STAR test.